Hey everybody, today we're going to be starting our unit on conic sections. Before we begin, I would like everyone to kind of scroll down if you're on your iPad or flip to the page that says conic sections overview. Okay, I just want to kind of describe what a conic section is before we start studying it. So a conic section is a curve formed as the intersection of a cone with a plane. So if you look at each of these pictures, we're going to take a cone and we're going to slice it right across, or we're going to slice it at an angle. That's what's going on here. And when you flip open the cone, you can imagine what that shape would be. So the three types of conic sections are the ellipse, the hyperbola, and the parabola. The circle is a special case of the ellipse, although some people sometimes consider it a fourth type. It's no big deal. We already went over circles in our last unit. So we have these different shapes that are formed as we slice through a cone. What mathematicians did was they took and they then put them on an XY axis. So we would have a circle, which we already studied, and we know the equation of a circle is x squared plus y squared equals r squared. And we have an ellipse. An ellipse looks really like a smushed circle, and that's what we're going to be talking about today. We have the parabola, which you've studied in your previous courses. We're going to study it a little bit differently in this course. And we have the hyperbola, which when we graph on an XY axis, it looks something like that. I mean, my pictures are not that great. This is just to give you a general idea of how the mathematicians took the picture and put it onto graph paper. So our mathematicians then came up with equations that model each of these conics. In this unit, we're going to be discussing the ellipse, the hyperbola, and the parabola using this geometric approach. So let's flip back up to the beginning of our lesson here. Today we're at Conics, Ellipses, Day 1. I'm going to start with the geometric definition in words. An ellipse is the set of all points P in the plane, the sum of whose distances from two fixed points called the foci is a constant. Now, I don't expect you to understand what that means. So I have my ellipse in front of me. What this geometric definition means is if I was to take any point on this ellipse and draw a line from the focus to that point and the focus to that point, what it means is the length of this line segment plus this line segment. No matter where I go on that curve, if I add up those line segments, the distances will be the same. Okay, and see, I'm connecting to the focus. Okay, so that's really, as you travel around that ellipse, that's what makes up the ellipse. And the equation of an ellipse, we're going to have two equations here. We're going to have a general form. We're going to have a standard form. The standard form is what we're going to use to graph. Okay. The general form is sometimes, what's given in higher levels of math. The general form is ax squared plus by squared plus cx plus dy plus e equal to 0. Now, in this general form, what's important here is in order for it to be an ellipse, our two values in front of the x and the y squared, the a and the b, those numbers are going to be different numbers, but we're going to have the same sign in between. So it's usually a plus. We don't really study anything differently in this class. And now what happens is we can kind of rewrite our expression, which we'll learn how to do tomorrow, but we can rewrite our equation in what we call standard form. And now what you'll notice is we have something that looks more like the equation of a circle. It's like a variation. And this equation, unfortunately, has two different ways we can write it. In the top version, the a squared is underneath the x term. And in the bottom version, the b squared is underneath the x term. We're going to talk about what the a and b represent in just a minute. Okay. Right now, I'm just going to tell you, if the a squared is under the x, our ellipse is going to kind of lay flat like that. And if the a squared is under the y, the ellipse, the longer part, is going to be vertical or parallel to the y-axis. Okay. Now, let's talk about some vocabulary that we're going to have to understand. So if we go back up to our picture above, we have, in our ellipse, we have a vertex, okay, or I could call them vertices. We have our endpoints. We have our focus or our foci, and we have our center. Okay, so everything's going to kind of be based off the center, and we're going to learn to describe each part. So we have all of our pieces or components on our picture. We have our equation in standard form. Let's talk about how we're going to relate some of this stuff together. So in an ellipse, just like in our circle, our H and K are going to make up the coordinates of our center. Now, a squared, when we're trying to figure out what's going on with our ellipse, we're always going to designate a squared as the larger denominator. Now, our a value, or the square root of a squared, is going to be the distance from the center to the vertex. In other words, if I'm on graph paper, it's going to be the number of boxes I count to get from my center to my vertex. This is going to be A. The B value is going to be the distance from the center to our end point. We go back up to our picture. Our B value is going to be however many boxes you count to get from the center to an endpoint. And our C value is going to be the distance from the center to the focus. I'm going to go in the opposite direction here. Center to focus. This is going to be C. That's going to be the number of boxes you count. Okay. And obviously, just like the circle, we're going to start from the center, go up, go down, sideways, sideways. Okay. So everything's going to be symmetrical to the center. Our major axis, okay, more vocabulary. Our major axis is the distance from one vertex to the other. You may or may not, depending on the type of question, you may have to know the length of it. The length of it is 2a. Obviously, that will make sense. I would have over here A, this distance over here, if we go all the way to the end, that would be A. Oops. That would be A. So the whole length is 2a. Okay. So the distance from vertex to vertex is called the major axis. We don't put it in our picture, okay. But if we're using words to describe something, we want to think about that. That's the major axis. And then we're going to formula to find missing information. Now, I don't know how mathematicians came up with this, but they did. There's a big long proof somewhere. I'm not going to try to show it to you or give it to you, just to memorize this formula. A squared equals B squared plus C squared. That's the relationship, okay, between our A, our B, and our C. Okay, so we just, I'm just trying to kind of give everything on one page, then we're going to work through an example. To graph an ellipse, the equation must be in standard form. What that means is it's got to be equal to 1. Okay, so you have to have a 1 on the other side. It's going to be different ways we're going to get there depending on the type of problem, so that's all I'm going to say for now. Now let's look at some practice questions. So we have an equation in front of us. We want to find the center, the vertices, the endpoints, and the foci of the following ellipse. We're going to graph the ellipse, and we're going to kind of remember that each of these things, center, vertices, endpoints, and foci, we're going to have to identify them on our page. So if it was a testing situation, I'd probably give you lines for each of these: center, vertices, endpoints, and foci. I usually just kind of write them on the side of the page. We're going to write them as ordered pairs, and then we're just going to have the information on our picture. I'm not going to identify every ordered pair with a label. I'm just going to kind of list it on the side there. We go back into our original equation. X squared over 25 plus y squared over 9 equals 1. Remember, first thing we do is start by identifying the a squared. A squared is the larger denominator, so a squared is 25, which means my b squared is 9. And I skipped a very critical step, identifying the center. For the center, you would look at what's attached to the x squared and the y squared, just like you would do with a circle. My center here is 0, 0. We're going to stay 0, 0 for all the examples today. Okay, so basically, there's no specific order you have to do things in, but I would start by plotting the center. And now I can plot my vertices and my endpoints by using A and B. If a squared is 25, a is going to be plus and minus 5. What that means is to get to the vertex, I'm going to use 5 units in either direction, and I'm moving horizontally because my a squared is under the x. And I usually just kind of go like that. Different textbooks will do different things. I kind of make it as simple as possible. So what are the coordinates of my vertices? Well, they're 5, 0 and negative 5, 0. And if you notice, all I did was add and subtract 5 from the center. 5, 0, negative 5, 0. Now I'm going to plot my endpoints. My endpoints are the B movement. B is under Y. So I'm going to go now, because I'm Y, I'm moving up and down. Up 3, that's an endpoint. Down 3, that's an endpoint. My ordered pairs, my coordinates of my endpoints, 0, 3, and 0, negative 3. Now, I'm going to stop for a second right here. That's my center, should have labeled that. And at this point, because you have the vertices and the endpoints, you really have your curve. You can just connect your dots. If I mess up, I'm sorry, it's kind of hard to draw on this thing. Your curve's not going to be perfect, don't worry about it. I'm looking for kind of just a connection between, you know, the ordered pairs and what you see on your picture. So now we need to just put the last piece of information in, and that's my foci. And if you remember, your foci is your C value. But I don't see the C value in the equation. That's where the missing information formula comes from. A squared equals B squared plus C squared. 25 equals 9 plus C squared. So C squared is going to equal 16. So C equals plus or minus 4 units. The vertices are always going to move in the same, the foci are always going to move in the same direction of the vertices. Okay, they're going to lie on that major axis. So I'm going to move from my center out 4 units. That's a foci. In the opposite direction, 4 units, that's a foci. I'm going to identify my ordered pairs or my coordinates, 4, 0, negative 4, 0. And there we have it. Okay, we've completed one problem. Okay. So it's really not that bad. There's a lot of little minute details that we want to, worry about and consider when we're moving through these problems, but they are straightforward, easy problems. Moving on to example 2. Now, in the beginning of the lesson, I mentioned that it's got to be equal to 1. Okay, I have 9x squared plus 4y squared equals 36. This is technically in general form, or very close to general form. I need to change this and have it equal to 1. So the way we're going to do that is we're going to take and we're going to divide each term by 36. As long as we do the same thing to each term, we're not changing anything. And then simplify this, x squared over 4 plus y squared over 9 equals 1. Now I have standard form. Now I can continue with graphing this. Center, vertices, endpoints, and foci. Center, go to see what's connected to your x and your y squared. There's nothing there, so my center is 0, 0. My vertices, oh, you can plot it while you're there. My vertices now, remember, you have to go with the a squared. So I start by looking, the a squared, the larger term this time is under my y value. What that means is I'm going to be moving longer in the y direction. So my ellipse is going to kind of be vertical this time. So I'm going to move off of my center, go up 3 and down 3. These are my vertices. 0, 3, 0, negative 3. Now I want my endpoints. My endpoints come from what's under the x term. I identify that as my b squared, so b is plus and minus 2. We're going to be moving on the x-axis this time. That's why I write it right underneath it, so I can't forget. Off the center, plus 2 in the opposite direction. Endpoint, endpoint. The ordered pairs for my endpoints, 2, 0, negative 2, 0. If you want at this point, and this is what I usually do, I connect my dots because then I don't mess up. The foci are not on the curve. They're points in the geometric definition that we graph in the curve, but they are not solutions. To get the foci, I'm going to go back over a squared equals b squared plus c squared. 9 equals 4 plus c squared. C squared equals 5, so c equals plus or minus radical 5. Now I have a little bit of a dilemma. How do I plot radical 5? How do I move radical 5 boxes? Well, basically, you estimate. Okay, we're not going to put decimals on our page. We're going to think in terms of square roots. So square root of 5 is really a number between 2 and 3, right? So we're going to count 2 boxes and a little bit. We're not going to make a big issue of it. Count up 2 and a little bit. Count down 2 and a little bit. So try to expand that a little bit so you could see. Okay, so notice I'm not quite on the 2. I'm making it just obvious to know that I moved off the 2 and I'm in between 2 and 3. Now, our y value of our center is changing. So I'm 0, I moved radical 5 units up, and my center, the x value is 0, and my y value is negative 5. If you prefer, and we're going to do this in future, you could write your ordered pair like that, especially when you're dealing with the radical signs. It makes it a little bit easier, but it's okay if you want to separate them out. That's no big deal. And so we're done with that picture. So what we're going to do now is we're going to write an equation of an ellipse. So now we're going to be given information and we're going to work backwards and come up with the equation. I love these. These are like a puzzle. Okay? They're actually really simple and easy. So basically my steps, again, just suggestions. Well, I'm going to plot any of the given information. I want to identify which equation to use. Now remember, we have 2 versions. X squared over A squared plus Y squared over B squared equals 1. And that's when my ellipse is flat. My major axis is parallel to the x-axis, and my ellipse lies vertically, or my major axis is parallel to the y-axis. I'm going to find any missing values, and then I substitute the values into the equation. Remember, A is the distance from center to vertex, B is the distance from the center to the endpoint, and C is the distance from the center to the focus. So, starting with the first example, we want to write an equation of the ellipse with the given properties. My center is at the origin, my focus is at the ordered pair 3, 0, and my vertex is at the ordered pair negative 4, 0. I'm going to start by kind of putting some information into my problem. Center's at the origin. This just means my h and k is 0 and using that smushed up version, right? The x squared version. My focus is at 3, 0. And my vertex is at negative 4, 0. So that tells me that my major axis is horizontal because the vertex and the vertex and foci lie on the major axis. So I'm going to be using the version that the a squared is under x. And in the problem, it's very easy to see that the c value is going to be 3. And my a value is going to be 4 units. I'm going to take that information and I'm going to put in what I know right now. I have x squared over, well, if a is 4, a squared is 16. Plus y squared over, I don't know what b squared is, but I can find b squared if I know a and c. A squared equals b squared plus c squared. 16 equals b squared plus 9. So b squared is 7. I don't even have to find the square root because I'm just popping it right into the equation. And that's how we work backwards and find an equation. This video might be running a little long, but we'll do one more problem. I have one focus at 0, 2, vertices at 0, negative 3, and 0, 3. Plot my given information. A focus at 0, 2, and vertices at 0, negative 3, and 0, 3. So right away, I could see that due to symmetry, my center is 0, 0, because I'm going to move out the same amount. I also can see that I'm plugging in my major axis is parallel to the y-axis, so I'm going to be using that other version where the a squared is under y. Now I'm going to go on my picture. Distance from center to vertex is a. The distance from the center to the focus is my c value, and that's going to be 3 units. Now I'm going to kind of use this information to replace the variables, right, the a's and the b's, with numbers. X squared over b squared. I don't know what b squared is, but if I know a and c, I sure know I can find b. 16 equals b squared plus 9. Oh, I did something wrong. Of course, I counted boxes stupidly. This is when you wish you were in the classroom. wipe this all out. This is definitely when you wish you were in the classroom. I plotted the points, right? 0, 2, focus, 0, 3, vertex. My focus is 2. My vertex is 3. I'm so sorry about that, guys. Okay, so let's kind of clear up that mess on your page. So now going back, a squared equals b squared plus c squared. I knew I was doing something wrong. I was just not stopping myself. I have 9 equals b squared plus 4. So b squared equals 5. X squared over 5 plus y squared over 9 equals 1. And there's your final version. So I appreciate you watching this video if you needed to, and thank you, and see you soon.